Good evening, everyone, and welcome to the first webinar of the Together for the Planet Youth, Faith and Climate Crisis series. Organized by the International Youth Alliance for Peace. I'm Abhilash Ranganathan of IYAP Volunteers, and I will be your host and moderator for today's session. We are excited to launch this series with a fundamental topic that is crucial to understanding the global climate crisis, the science of climate change, understanding the basics. Before we dive into today's discussion, let me take a moment to introduce the broader purpose of this initiative and how we will progress over the coming months. This webinar series is part of IYAP's ongoing commitment to empowering young people and faith-based communities to act on climate change by combining scientific knowledge with ethical and moral insights drawn from various faith traditions. We aim to inspire and equip participants to take meaningful, sustainable action. The program will cover a range of interconnected topics for over several months, from environmental justice and policy to role of traditional knowledge and youth activism. At IYAP, we believe that knowledge is the foundation for change. That's why today's session is designed to lay the groundwork by exploring the core science behind climate change. Understanding these basics will help us grasp the gravity of the climate crisis and inform our future efforts. A quick note for participants. Those who attend 9 out of 10 webinars in this series will be awarded a certificate recognizing their dedication to the program. Over the next few months, we'll cover themes such as climate justice, faith-driven environmental advocacy, traditional knowledge, and sustainable business models. But for today, we are focusing on understanding the basic science behind the climate crisis. To start off, we are honored to have two panelists for today's sessions, Dr. Ganapathy Gajapathy and Mrs. Arundhati, Professor from University of Colombo. Dr. Ganapathy Gajapathy with us for today's session. Dr. Gajapathy is a professor in the Department of Zoology at the University of Jaffna with over 15 years of experience in ecology, biodiversity, conservation, and environmental science. His work spans research, advocacy for sustainable practices, and youth engagement in climate leadership. His passion for educating young people on the impact of. Before we begin, just a quick reminder. If you have any questions during the session, them in the Q&A section in the Zoom, and we will address them during the last 15 minutes of the webinar. Now, without further ado, it is my pleasure to hand over the floor to Dr. Ganapathy Gajapathy to lead us in today's session on the science of climate change, understanding the basics. Dr. Gajapathy, over to you.
Thank you. Thanks a lot, Iger, for inviting me for these sessions, number one. And I will, can I share my screen if that is possible? Is there any possibility to share my screen?
Yes, sir. Sure.
Yeah.
You can share your screen.
Yeah. Thank you. I have made a small presentation to share with you with some scattered information. I just want to give you an update about the science behind the climate change. Starting with this, can any one of you say what exactly is this gentleman holding in his hand? You can speak. Any guesses? Or you can put that in your chat box here. I got some messages. Can, yes, of course. What is inside that can? Any guesses? Yes. Okay. Yeah, you can speak. Energy drink. Yeah, maybe. Any other guesses? Okay. The gentleman is holding a can full of oxygen. Right. So this is in China where the air is so polluted. The oxygen is sold in can. Right. So that you can get a can, right? Just like you grab a Coca-Cola or Pepsi, or even any other drink, you can have this oxygen inhaled into your system. So I just want to share this picture to make sure that you understand the world we are in now. Right? So, just like any other thing, our earth is also changing. Right? Since the start of the formation of our earth, it has been changed constantly. Right? There is a saying in Tamil that only thing that doesn't change is the change. So, hence the formation of the earth, right? Some 4.5 billion years ago. You should know how the earth was formed, right? We have a famous theory called Big Bang to support the formation of the earth and the other planetary system. So this earth, when it was first formed, is like a fireball, right? Full of energy, full of heat, and not like the earth what we are seeing today. It was very different, right? When the earth was first formed, it is full of dust, burning dust, right? With different composition of whatever we are seeing now around us and inside the earth as well. So this differentiation of the early earth from a fireball to what we are seeing now, right, is the change that has been done for over billions of years. Right? So this earth was just like how we see our sun now. Right? It was very hot, not hospitable or inhabitable for any organisms. And the atmosphere is also different. Right? So this can be seen now, right? We know the earth core, inside the earth now, we have a crust, right? And inside we still have the hot lava or magma, right? Which is the earth's surface was like that in the early stages, right? Very heavy rainfall and all these things solidify the crust of the earth, right? And when you look at the atmosphere, right? When you look at the atmosphere, it was not the same as well, right? So the primitive atmosphere, what we call, was not having the same atmosphere what we are experiencing now. Most of the gases were just like the gases now we are seeing in the sun, right? So the differences in this atmosphere or the changes in the atmosphere has to be understood to understand what is happening around us now in the term of global warming, right? So if you think about the atmosphere at the early stages, we don't have whatever the common gases we are experiencing around the atmosphere now, right? Specifically, we never had oxygen, free oxygen, right? So if you can see this graph, you can see the early atmospheric composition, right? So how this has been changed is, right? So this is the composition of early atmosphere. So how this has been changed is because of the evolution that happened around the earth as well as the radiation or dissociation of water due to the radiation, right? So if you can see the evolution of oxygen in the earth's atmosphere, it has been started first during the dissociation that happens at the molecular level. The water molecule, when they experience ultraviolet rays, they gives away the oxygen. That's the first oxygen, free oxygen that has been created in our atmosphere, right? And then the inevitable happened, right? The evolution of photosynthetic organism, we call that, because earlier we didn't have the photosynthetic organism. A photosynthetic organism, just like the plants, the early organisms, which can intake carbon dioxide and exhale oxygen during that process. So the cyanobacteria at the place when they first become abundant, and they created the mass amount of oxygen in our atmosphere. right? So this is how our atmosphere changed over time. Right? This is a story of billions of years. Right? So what we are looking at now is slightly different. Right? So our atmosphere, even though that is changed over billions of years ago, say for example, it's 2.5 billion years ago when the first oxygen has been formed at a significant level, this has never remained the same. The same story applied to carbon dioxide as well, right? So if you look at the different periods over the history of Earth, there are various eras or epochs, right? Those are the terms defined to define certain time frame in our history of Earth. In Carboniferous, right? So it is one of the best period in the history of Earth when the oxygen level actually doubled. It was around 20%. It was 40% during that time. Whereas in Permian and Triassic, another period where it was dropped down to 15%. So the changes in the composition of the atmospheric gases happened throughout the history of Earth. Right? We have to understand that fact. And the second important aspect I want you to understand is the contrasting difference between climate and weather. Right? So weather is a particular notion we use to measure the condition of the atmosphere at a particular point, at a particular space and time. Right? It is more like a very small scale. Right? Whereas climate is an average weather for a defined region over a long period of time. Right? So what we are looking at today as whether we get rain or the temperature or the RH, we call it as weather observations. Whereas if you measure them over a long period of time, we call it as climate. Right? So whatever we are trying to speak as climate change or global warming is what we have synthesized the data over a long period of time and what is exactly happening in that data, right? So when you talk about the global warming, we talk about the greenhouse gases as well, right? So you know what the greenhouse gas is. The greenhouse gas or greenhouse gases, there are so many gases which can be classified as greenhouse gases, which can actually scatter back the IR radiation, right? So whether greenhouse gases, which the effect is called as greenhouse effect because it is more or less mimicking whatever we are having, whatever we are seeing in a greenhouse where we grow plants, where the temperature is kept inside at a higher temperature, right? So greenhouse effect, the scattering back of the radiation, as you can see, right? So just to see that Earth gets the radiation, right? Shortwave radiation from the sun, and it is reflected in the atmosphere and goes back. And most of them reaches the Earth's surface and go back as the long wave radiation, close to the IRA, the heat radiation. And if it goes back, it is fine, right? The temperature is not scattered back. But what the greenhouse gases are doing is they actually scatter some of these radiations back. So that's why we get the heat at the surface of the Earth. So greenhouse effect is a natural effect. It is not a human-made effect, right? Without greenhouse effect, our Earth will be much close to the 0 degrees Celsius, right? Just like the polar region, our Earth will be full of ice. So whether greenhouse effect is good, yes, it is good. That's why our Earth is inhabitable by organisms. That's why we are living here. But what is happening now is unexpected increase in the greenhouse gases which makes this effect severe, right? So that more carbon dioxide or more methane or more H2O vapor are released in the atmosphere. So rather than the average greenhouse effect, what we are getting is more heat or IR wave are being scattered back to the Earth's surfaces. So we are experiencing unexpected or unnatural heating impact on the surface of the Earth. So that is what we call it as global warming, right? So this is a picture I just want to show you how the level of carbon dioxide, one of the primary greenhouse gas, has been changing over time and along with the temperature, right? The red line is the temperature and the purple line is the carbon dioxide. As you can see, right, the carbon dioxide level was much higher during the history as well. It came back, right? And most of these increment has happened because of the natural causes, volcanic eruptions to be precise, right? But what we are experiencing now is human-made increment, right? Which is not normal as we thought, because this increment cannot be reversed back, right? As you can see from this diagram, this increment is far beyond what we have experienced over the course of the history of Earth, right? So why this has happened? Because we are emitting so much of greenhouse gases. This increment in global temperature is meant to be human made, not natural. Right, I just keep some slide. So what is the problem now? Because most of these people who are, some of them are powerful, are not believing it. So that's one of the problems. So we have to act now, right? So this cartoon implies, right? So tomorrow it may be too late to act. So it's the time to act, right? So I just want to share some facts with you. For the last minute, right? So this is what we are experiencing now, right? So this is what, so we knew this earlier. In 1960s onwards, most of the scientists were fighting against this, right? And but nothing has changed much. So that's why we want the youngsters to be part of this movement and create a better world. If you want to read more about these things, I just want to share these links. I don't need to share this. If you Google it, you will find a lot of other information other than that. So thank you very much. Yes, thank you.
Yes, thank you, Doctor, for your thorough explanation and insights on clarifying distinctions between climate, weather, and the atmosphere. So, the explanations helped us to better understand how these elements are interconnected and influence on one another. So, next, we'll move on to our second theme, climate change effect on weather patterns. So, for that, I would like to call upon Professor Arundhati Lokupitiya, who is a PhD holder from Colorado State University, USA, focusing on climate change and land atmosphere carbon exchange. So she was a research scientist at Colorado State University from 2006 to 2011 before joining the University of Colombo in 2012. So where she is now a professor in environmental science. So she has led several national and international research projects on climate change and served as the national expert for Sri Lanka's greenhouse gas inventory. So currently, she is the national consultant for mitigation under the Ministry of Environment's capacity building project and coordinates the MSc in climate change and environmental management. So we are so humbled to have you on board, Professor. The stage is yours.
Thank you very much. And first of all, I want to thank you for inviting me for today's talk. So let me share my screen. I hope you all can see my screen. Can you? Can you see the screen, please?
Yes, we can see the screen.
Okay, so the title you all gave me was the impact of climate change. So since Dr. Kanapati mentioned about the basics of greenhouse effect, I'm not going to touch upon that part, but I would like to bring to your attention what we really mean by climate change. Actually, according to the Climate Change Convention or the United Nations Framework Convention on Climate change means a change of climate which is attributed directly or indirectly to human activity that alters the composition of the global atmosphere and which is in addition to natural climate variability observed over comparable time periods. So as you all know, this is something we all have been responsible for. Climate change means something we all have been responsible for. Just like Dr. Kanapati mentioned, we need these greenhouse gases. They are very essential for life on Earth. If we didn't have these greenhouse gases in the atmosphere, our Earth would have been freezing cold. So they are essential for us to survive on Earth. But when we artificially increase those greenhouse gases, we have led to global warming, what we experience today. So that's why we are responsible for that, and it's directly or indirectly attributed to our activity only because we have altered our uh, atmospheric composition by releasing these greenhouse gases through our activities. So this is the famous Keeling curve, which shows the CO2 concentration, the increase of CO2 concentration over time. He started these measurements in 1958, and actually this goes only up to 2005, but now this CO2 concentration has even exceeded 400, right? So now you cannot say the CO2 percentage in our atmosphere is 0.03. You cannot say that because now we have passed 400 ppm. If you convert 400 ppm, it would become 0.04% of CO2 in the atmosphere. So we have increased our CO2 concentration continuously. And this shows the temperature anomaly. That means compared to the global average temperature, how the Earth's temperature has changed over time, starting from the record when the temperature record started. That means in 1880 only the temperature record started. This is how the temperature has changed over time compared to the global average. Then you call it the temperature anomaly. So you can see, if you consider this period 1952 past 2000, then even the temperature has been continuously increasing only. So this clearly shows the correlation between the increasing CO2 concentration and the global warming or rise in the temperature over time. So now we call almost every year, we say the last 7 years, last 8 years were the hottest on Earth. So this is something we mentioned in, I think, 2021. Last 7 years ranked as top 7 hottest. 2016 was the warmest. So this is what we said in 2021. Then this is in 2023. We said the last 8 years were the hottest on record. So every decade we say the last decade was the hottest decade on Earth. And so this is another one. 2022 was world's 6th warmest year on record. When you consider the temperature records on Earth starting from 1880. 2022 was the 6th, and we say the last 8 years were the hottest, like that. So just like similarly to that, so this is another one. With the temperature rise, then there is melting of glaciers, melting of sea ice. So this slide says the Arctic and Antarctic saw record warmth and ice melt in 2022. Argentina's record-breaking 2022 heat wave made 60 times more likely by climate change. So even in the coldest places, there have been a lot of changes, melting of ice, glaciers, and also heat waves in Argentina, like that. And by the end of the last year, we were saying it was the warmest year so far on Earth. It has been the warmest year so far on Earth, 2023. Let me see if I can. World is dangerously close to a global warming limit as 2023 goes down as hottest on record. So we have been experiencing so many changes in our climate due to our activities. Then I am supposed to talk about the impacts. So impacts due to increased temperature. So when the temperatures are high, all the bad organisms like pests and disease-causing pathogens, they are very happy, So increased damage from pests. Even in forests, there is so much damage from increased number of pests. Even hardy trees like conifers, sometimes they can become completely brown due to pest attacks. For example, in the USA, in Colorado, where I was, there are long stretches of brown coniferous forests now. Coniferous forests are evergreen forests, but due to climate change, there is this pest, pine beetle. Pine beetle attack is very bad. It's very badly happening there, and you can see hectares and hectares of forest die back due to pests. This pest. So and also changes in vegetation phenology. So with the temperature rise, there is a change in the life cycle of a plant. It could be shortened or it could be lengthened, plus the time taken to shift from one stage to another, that would be changed. You call it phenology, like time of flowering, seeding, becoming mature, those shifting from one stage to the another one, you call it phenology. So if the plant needs to accumulate heat units to move from one stage to the other one, the next one, if the plant accumulates those very soon because of the high temperature, then the life cycle of the plant can be shortened. Its lifespan can be shortened, and sometimes the temperature could be too high and you might not even reach certain stages. So there are things like that, changes in vegetation phenology, impacts on biodiversity, damages due to droughts, floods, and other extreme events, thawing of permafrost in areas such as Arctic tundra. Arctic Circle is at around 66.5 degrees latitude, and there you have this tundra vegetation, and it's that part of the world is covered by permafrost. We call it permanently frozen ground, because up to a depth of more than 1,000 feet, the ground is completely frozen. But because of the warming now, this frozen ground is thawing up. Then it has led to a lot of bad impacts. Even their infrastructure has been impacted, their housing and everything is has become very unstable because of the thawing of permafrost. And so loss of biodiversity, impacts on biodiversity, loss of biodiversity and higher rates of extinction due to increased temperature, changes in precipitation, extreme events, and sea level rise. So with the increased temperatures, we have been experiencing changes in precipitation as well, because high temperatures would lead to increased evapotranspiration. Then it will cause accumulation of a lot of water vapor in the atmosphere, causing more and more heat accumulation. When you have a lot of water vapor in the atmosphere, water vapor can absorb heat more, and then it would cause long drought periods. But then sometimes there would be a change in the atmosphere, because our atmosphere is in constant circulation. Then suddenly all this water vapor can condense and form rain, and bring us a lot of floods. So that's why we have been experiencing alternating droughts and floods, And even with the slightest temperature rise, certain sensitive species can go extinct. We have been experiencing that as well. Certain butterflies, certain very important species, we don't see them now. And this can affect their species composition because certain species, when they go extinct, it will lead to changes in the overall species composition at a given locality. And it can affect population structure and size as well, because heat mostly affects the elderly and the juvenile stages, right? Immature and very old generations and infants, so juvenile stages in the population. So even that can lead to changes in populations in many organisms. And also with the temperature rise, you see shift in vegetation boundaries and zones and higher frequency of epidemics and pest outbreaks. We have been experiencing this. So with the pest outbreaks, even in this South Asian region, our entire agriculture is in danger due to extreme events, continuous floods, droughts, pest outbreaks. So all the farming areas in this region they are under threat now due to climate change. It's like our region is like next to Africa only in terms of food insecurity, I would say. So also vegetation damage and inability to survive due to sea level rise. Even sea level rise can lead to changes in coastal vegetation, mangroves, and other forested areas, and also decreased availability of light for corals, which would affect the photosynthesis process, and impacts on coastal ecosystems, loss of biodiversity, and impacts on human settlements, hydrological impacts, because coastal sea level rise can cause saltwater intrusion, impacting coastal agriculture, plus also drinking water in coastal regions. So these are some of the pictures as evidence of what I was saying. Melting of glaciers. So this is how this glacier was in 1928, and this is how it was in 2004. So this is a picture from several pictures from Alaska. Actually, I visited Alaska. It's very beautiful, and this is a picture of a glacial lake, a lake formed due to melting of glaciers, right? So melting of glaciers is pretty much evident there. And thawing of permafrost, even this is very common, as I said, in the Arctic Circle. Alaska is also coming under the Arctic Circle. So there you can see in Alaska thawing of permafrost. So when this frozen ground thaws up, even that can lead to emission of methane. As you all know, methane has a much higher global warming potential compared to carbon dioxide. So unexpected future boost of methane possible from Arctic permafrost, thawing of permafrost. Then let's talk about some other impacts. As I said, increased forest damage from pests. Coniferous trees can become brown. Actually, what I was referring to was even more greener than this one actually. The dieback from pine beetle. So increased sea levels, pests, and high temperatures and extreme events all have affected the agriculture and food security. And bleaching of corals. And these animals, so polar bears, they feed on these thin ice sheets. Now, due to melting of ice sheets, their fishing grounds are vanishing now. And increased occurrence of extreme events, continuous, almost every year since 2010 or so, we have been experiencing some kind of a drought or flood in this country. So it's the same all around the world. China, Europe, US drought is 2022, the driest year recorded. This is something, a picture from 2022. So this is a lake. You can see, this was completely underwater, but with the drying of the entire lake, now even some ancient things have been showing up. So this is a picture from China, and this is another picture from Lake Mead, Nevada, USA. So you can see even certain ancient things are showing up now due to drying up of the water of these Lake Mead. Summer floods in Kentucky, USA. So this is all these are from 2022. Okay, so this is Kentucky, USA. Summer floods, and this is again melting glaciers and intensified monsoon rains caused devastating floods in Pakistan, which killed 1,739 people. Even there are records about Sri Lanka, about the impact from devastating floods in these countries. So I have taken only few. The year 2022 was marked by record droughts, heat waves, forest fires, floods, and a record low level of the Antarctic sea ice. So, but this is 2022, even 2023. Now we say it has been the warmest year so far. There had been wildfires, heat waves, lot of events. And so these are more pictures from landslides, hurricanes, all these provide evidence for existing climate change. And US heat-related fatalities, 1986 to 2011. So heat waves, even in Sri Lanka, early this year, we experienced some heat wave. So climate change-related disasters, they are very costly, and it can mostly impact the poor people. And it has been very unfair when it comes to when you consider the behavior of the rich people and the poor people, plus the impacts they are facing, it has been very unfair or inequalities. There are too much inequalities there. When you consider the global CO2 emissions, richest 10% emit 49% of the global greenhouse gas emissions, but poorest 50% emit only 10%. So you can see the poorest countries, their contribution is very low, whereas the richest 10% emit close to 50% of the global emissions. So, so how can we reduce our emissions and our impacts? There are two things we could do in handling climate change. Adaptation is aimed at reducing the impacts. So two things you can do is take action to reduce the impacts, then you call it adaptation. Mitigation is the action you take to reduce the emissions, causes of climate change. So adaptation measures are normally taken in sectors such as agriculture, health, and so on. Of course, agriculture sector emits greenhouse gases as well. But agriculture sector now, because we are very vulnerable, farmers are very vulnerable. Now they are being introduced to new varieties, drought-tolerant varieties, salt-tolerant varieties, like that. So those are adaptation measures. And then mitigation measures are to reduce emissions, reforestation efforts. So if you plant more trees, the trees would absorb more and more carbon dioxide. Renewable energy, clean energy options, energy efficient equipment, improved management practices, then maintaining environmental standards, all these things will help reduce emissions, right? So now we are talking about the Paris Agreement, and under the Paris Agreement, the global nations are planning to become carbon net zero by 2050. Why? To keep the temperature rise within the century to well below 2 degrees Celsius compared to pre-industrial levels. Because if the temperature would increase at this rate, by the end of the century, it would be about 5-6 degrees Celsius higher, and it would be very bad for humans to survive, not even humans, even for the animals to survive. So now there is this very ambitious target goal under the Paris Agreement to keep this temperature rise well below 2 degrees Celsius, and we all as global nations are trying to reduce our emissions and become carbon neutral by 2050 through national level action. We call those NDCs, nationally determined contributions. So we have national determined contributions prepared for these different sectors to become to reduce our emissions. So we have to think globally, because at Paris Agreement and everything, we are trying to reach these global goals to reduce our emissions, but we have to think locally. As individuals, we have to be concerned about our carbon footprint, minimizing our emissions. So you need to be concerned about minimize what you release to the environment. You need to be concerned about minimizing your waste generation, resource use, consume only what you need, reduce what you dump to our environment, as it can lead to greenhouse gas emissions. All the mixed waste ending up in landfill sites can lead to methane emissions. So you have to be very much concerned, and also stay away from single-use plastics. If possible, shopping bags, lunch sheets, because now the problem is fossil fuel burning. The biggest cause for climate change has been industrial revolution and fossil fuel burning since then. And even single-use plastics, they incorporate a lot of fossil fuels. So you need to be mindful, try to avoid the use of single-use plastics. Take a water bottle, durable one, metal one, or a glass bottle, and you please try to carry your lunch box instead of carrying your lunch in single-use plastics. Plastic bags can increase the transmission of vector-borne disease like malaria. So there are so many problems. High concentrations of plastic materials, particularly plastic bags, have been found blocking the airways and stomachs of hundreds of species. Plastic bags are often ingested by turtles and dolphins who mistake them for food. So this is only a chapter, a small para from report I read. So you have to be very mindful. And now we all are talking about SDGs, Sustainable Development Goals. We need to pay attention on that, because even Sustainable Development Goals were adopted. One purpose was tackling climate change. So SDG 13, it's about climate action. And I think the most important one is SDG 12, responsible consumption and production. If we have been responsible in our consumption and production, then we wouldn't have been facing all these environmental problems we are facing today. We have been very unsustainably using our resources, emitting unnecessary gases, dumping, releasing unnecessary waste material, pollutants. That is all because of the irresponsible consumption and production. So this climate action is very much linked to responsible consumption and production. So we need to be mindful, because the target for achieving these SDGs is only few years away, 3-4 years away, because we are supposed to achieve these SDGs by 2030, right? So in summary, since I have been given only up to 20 minutes, we as humans have been responsible for the climate change impacts we experience today. Global, local, and individual level action is essential in finding solutions. Concern about the environment and attitudinal change, they are key to successful implementation of the local and individual level action. So we have to be mindful in whatever we do. You have to love your environment. You have to be mindful in whatever you consume, because you have to make sure that you are not further damaging your environment. I think that's enough. Thank you very much.
Yes, ma'am. Thank you for insightful presentation, Professor. Thank you so much for your clear, informative explanation on global warming, and the expertise and clear explanation added tremendous value to our webinar. So, and we are we have to inform that the live session will be ended by now, and you can have the recordings on our social media.